Alrighty, now this morning we're going to talk about weather, particularly from a private pilot oral point of view. Okay, so your examiner is going to ask you about weather. As you're doing your pre-flight briefing and explanation, some of the things that you specifically need to be aware of: clouds. Okay, so how high are the clouds? And then we'll get into what kind of clouds they are. But if we don't have this, like I say, if we don't have a 1,000-foot ceiling, a 1,000-foot ceiling means we can be 500 feet below the clouds and 500 feet above that random house if we're in a rural area. So that's why we have the 1,000-foot for the Class E airspace. But even in Class G, the 1,000-foot's not a bad thing. Okay, so we want to start with 1,000 feet. Your personal minimums are going to be higher than that, but we need to know how high the clouds are. If we're going to go out and do stalls, we need to be able to get above 1,500 feet above the surface and still be 500 feet below the clouds. So now that we need a 2,000-foot ceiling, that just gives us the bare minimum. So we need more than that. So the cloud height is a particular element. Visibility. Okay. The rules say in Class G I only need 1 mile. In Class E I need 3 miles. If you think that's acceptable for you, you might be having a hazardous attitude. Okay, so 1 mile means that's typically the length of the runway. So if the winds are calm and you're on final, somebody else is on final, 1 mile visibility means y'all meet in the middle. Okay, going to be an ugly situation. So you're going to set your personal minimums for the clouds, but you're going to set your personal minimums for the visibility. My personal recommendation is 10 miles. Why 10 miles? Because that's the highest value we can get off any of our automated weather systems. I like more than that, but I would not let any of my students or new pilots set their visibility minimums or personal minimums below 10 miles without some serious consideration. Okay, once you fly and you're on your own, it's up to you. My recommendation is when you see that weather machine saying it's 7 or 8 miles, run out to the airport, stay in the pattern, look out the window and see what you see. And we're going to talk about some of this in the cross-country planning. So the clouds, the visibility, wind. How strong are the winds? Okay, the examiner certainly has a limitation. Their guidance says not more than a 25-knot wind for the check ride. Okay, somebody asked me once, does that mean steady state or does that mean gusty? The answer is like, really? Is that the question you want to ask? Okay, so if it's gusting to 25, probably do you really want to be doing turns around a point? What if it turns into a crosswind? What are your personal minimums for a crosswind? So if I've got the airplane has a limitation. Yes, you're going to say, no it doesn't, it has a recommended. No, every airplane has a limitation. That limitation is when you run out of aileron and rudder and can no longer manage the airplane. That is that airplane's limitation. Okay, whatever that is, who knows? It's not typically in the book. Most of our training airplanes have a demonstrated crosswind maximum. That meant they went to Strother Field in Kansas and they test flew that airplane and they had a 14-knot crosswind that day, and that was the maximum crosswind that they could demonstrate. Okay, it's not a limitation. Whatever you can manage. Now again, your personal limitations, maybe you're competent at 10, but at 14 or 15, you start kind of having trouble because of your personal ability to manage it. So you know what your personal crosswind limitations are. So these are the things that we want to be reviewing. So the clouds, the visibility, the wind, and then another one, density, altitude. Okay. Right now we're thinking it's March. We don't have a lot of density altitude issues. But let's look at June and July and August, and particularly if we're going into high altitude airports, this density altitude is going to be a huge factor. So we need to, if you're taking a check ride in March, they still ought to be asking you about density altitude. Okay, I asked the question once of a young man, tell me what you know about density altitude. His answer was, density altitude is pressure altitude corrected for non-standard temperature. That is the book answer. What does that mean? And then he kind of gave me the deer in the headlight look. Okay, so I don't want the book answer. It's good to know it, but the book, that's not really what I want. That's a test question answer. Okay, what I really want you to know is that when I'm at a high density altitude, I've got fewer molecules, and those molecules are for my wing to produce the lift. The molecules are for my propeller to produce thrust, and those molecules are for my engine to produce power. So if I've got fewer molecules, all those three things lose efficiency, and my airplane loses performance. Okay, so what I can do at a 6,000 foot elevation airport today, when it's 50 degrees outside, is vastly different than what I can do at that same airport when it's 90 or 100 degrees outside. So we want to be understanding density altitude again. So we're looking at it affects my wing, it affects the propeller, and it affects the engine. And basically it's all about the molecules. Humidity has a factor in this. It's more difficult to find that information, but high humidity, again, I talk about the water molecules. They take up space, but they don't do much work. Okay, I like to talk about my molecules. My air molecules are little weightlifters, and they push up on my wing, they push on my propeller, and they go to the engine and they do their thing in the engine. My water molecules, they're kind of lazy. They just sit around and do nothing. So all the others, little worker bees, are out there. So if they're taking up space, I don't have my worker bees for my wing and my propeller, and my engine says, why are you feeding me water? I can't use water. So those humidity molecules, they're just wasting space. Okay, so understanding density, altitude. Can y'all think of anything else that I can, on the weather, that I need to, temperature dew point. Mm-hmm. Okay, so temperature and dew point. Obviously the temperature is a huge factor in the density altitude, but now today, particularly here in Vernon, Texas, the temperature dew point is a bigger factor. Okay, when the temperature and the dew point start moving together, the moisture in the air is going to condense. When that moisture in the air condenses, it could be frost if it's below freezing, it could be dew, which is the wet stuff on the grass, or it could be fog. All right, so don't take this to the bank, but quite often if you walk out the door and there's dew on the ground, it's unlikely that fog is going to form. The moisture has already started condensing. But don't go flying anyway, just because you don't have to. But when, like I say, but if it's, again, within 4 degrees Fahrenheit or 2 degrees Celsius, you want to make sure that those temperature and dew point are moving apart before you jump in the airplane. Because that fog can form literally in minutes. You're like, say, yeah, you can tell me, well, I'm not going to be more than 5 minutes from the airport. Well, guess what, folks? You can lose the airport when you're on the downwind. Okay, you don't want that to happen to you. And fog is kind of a weird thing. So I could go on hours about fog, and I won't. And so we can talk about briefly, and again, checkride examiners. What kind of fog do we have? In this part of the country, we're in north central Texas, most of our fog is radiation fog. So the ground changes the temperature of the air, and it radiates. The ground is cooler, so it radiates that cooling to the air, cools off that air, boom, fog forms. Okay, so we get the radiation fog. In this part of the country, it typically happens early in the mornings, right around sunrise. So people get in trouble because, I've got to be somewhere at 8 a.m., I'm going to leave at 6:30 in the morning, just about 30 minutes before the sun comes up. And I do that, and just as the sun comes up, the world goes away. And I'm over a sea of white. And if you don't have an instrument rating, it's a little scary. If you do have an instrument rating, it can be quite scary. Okay, so fair enough, right? So we have the radiation fog. Pardon my lack of penmanship. So we have radiation fog. If you live in San Francisco, other places like that, we have advection fog. Okay, underlying words, this one, radiation, the ground radiates that temperature change. Advection, if you've ever heard of convection oven, so the underlying word here is vector. So that there's a vector. So the air over the ocean moves inland, and it changes temperature when it moves inland. Boom, we have the San Francisco fog. Okay, it happens in other places, so it's sea fog. It moves in, and whatever time of day, again, it's dependent on the wind. So the wind blows that moist air inland, and we have fog. Okay, and I'm not terribly familiar with that part of the country, so understanding wherever part of the country you live in, you need to be very educated on how it forms in your part of the world. Okay, then we have upslope fog. Okay, Colorado, wind blows and it moves that air up a mountain, because once it hits the mountain, it doesn't have any place to go but up. And as it goes up, the temperature cools off. And as it cools off, boom, we have upslope fog. Okay, or if you're sitting on the ground and you're looking up there and it's like, oh, look, the mountains are covered in clouds. Okay, there's not much difference between a fog and a cloud, other than the fog is touching the ground and the cloud typically isn't. Okay, so upslope fog, and then we also have steam fog. Okay, so this is coming off of frozen lakes and what have you, and doing weird things. Steam fog is fairly isolated and not something I spend a lot of time on. Okay, but these are the three that we need to be, and actually the radiation and advection fog are the two that we need to be primarily the most concerned about. Any questions on fog? It can form very, very quickly, and fog is weird. You know, flying once, I can see the ground perfectly, everything is great. I'm coming into land, don't see any problems, I'm 50 feet off the ground, and the world goes white. I've got vertical visibility, but I have absolutely zero forward visibility. That was interesting. Needless to say, I survived it. But understanding there's all kinds of weird fogs out there. So these are the main elements, and then we can look at what causes some of these particular things. Check my time here. Where are we? Okay, we're 11 minutes. All right. So we're gonna take just so you know, we're uploading this to whatever source we can. So we're gonna take some breaks here. So next up will be thunderstorms.